This video will go through one way in which we can solve exponential equations with a few different examples. In the next chapter, we're going to learn another way to solve exponential equations, which uses logarithms. If you remember, an exponential function has a variable as part of its exponent, so it makes sense that an exponential equation also has a variable as part of an exponent. Let's look at an example. Here we have the equation 2 to the x equals 16. It's an exponential equation because its variable is an exponent. Now you're probably thinking you already know the answer to this question, and we don't really have to do much work to solve this. We could just think to ourselves, 2 to what power is 16? And the answer would be 4, so x is 4. However, not every equation will be so simple, so the method we're going to learn in this video is to try and get both sides of the equation to have the same base. I would pause the video to write that down. So using this example, we can see that we have 2 to the x, and we could write 16 as a power of 2 as well. 16 is 2 to the 4th. Now that both sides have a base of 2, and we're talking about an equation, the two exponents must be equal, because 2 to the x can only equal 2 to the 4th in this case, so x must be 4. Let's look at another example. Here we have 3 to the x equals 1 over 27, and if you remember, when we have something with a power in the denominator, it's likely we're going to involve negative exponents. Maybe you're also able to solve this one without doing any work, but let's practice rewriting the equation so that both sides have the same base. Now, 27 is definitely a power of 3. It's 3 to the 3rd. So this is really 1 over 3 to the 3rd, but because 3 to the 3rd is in the denominator, we could rewrite this as 3 to the negative 3rd. Now that we have both sides with the same base of 3, we can set the exponents equal, and again, x is negative 3, pretty straightforward. Let's look at a third example. In this example, we have a base of 4 and a base of 8. Now, 8 is technically could be a power of 4, but it would mean the exponent was a fraction. I would have to raise 8 to a fraction to get 4. So while you could try and work that out, it's easier to break both of these bases down to powers that they both are. So for example, 4 is a power of 2, it's 2 squared, and 8 is a power of 2, it's 2 to the 3rd. So we could rewrite this making both 4 and 8 base 2. So 4 would be 2 squared, and then since that's being raised to the x minus 2, I need to use some more parentheses here. You might want to overdo your parentheses so that you can see we're going to have to distribute this exponent here because I'm raising this power to another power, and we learned that we multiply exponents when we're doing that. And then on the right, 8, as we said, is 2 cubed. So now if I keep working with this, if I do what I said and distribute this exponent here, 2 is really being raised to the 2x minus 4. And on the right-hand side, we still have 2 to the 3rd. And now that I have the bases equal, I can set the exponents equal because this must equal 2 to the 3rd. And since they're both base 2, this must be 3. So we rewrite it as 2x minus 4 equals 3. And now this is a basic algebra equation for us to solve. We move 4 to the other side and we get 2x is 7. And when we divide both sides by 2, we get 7 halves or 3.5. So that one is not as straightforward, maybe not easy to just see what the answer is by looking at it. Here's another example, and as you can see, they're getting a bit more complicated. So this is still an exponential equation because hiding in here I do have 5 to the x, so I have an exponent that is a variable, but I also have a lot of other things going on here. So we have to follow our rules for solving equations. I'm first going to get rid of what's around 5 to the x in the order in which we do that. So I'm first going to move minus 20 to the other side by adding it, and then I'm going to divide by 4. So first I'll move the 20 to the other side, and we're left with 4 times 5 to the x is now 100. Then I will divide both sides by 4, because 4 in this case is not being raised to the x. 4 is being raised to the first power. So I'm going to divide both sides by 4. And then I'm left with 5 to the x is 25. And now this isn't so bad. You don't need to really rewrite this with powers of the same base here on both sides. We know that 5 squared is 25, so x must be 2. Here's our final example, and as you can see, it's our most complicated one. I have variables as exponents on both sides of the equation. I also have multiple bases here that I have to work with. I hope it's clear that each of these is a power of 3. So my first step will be to rewrite each of them using a base of 3. So 9 will be 3 squared. The second one is already base 3, so I will just rewrite it. But now remember, I'm multiplying common bases, and when we're multiplying common bases, hopefully you're already thinking, I get to add exponents. On the right-hand side, we already worked with 1 over 27 once today. So that's 1 over 3 to the third, which becomes 3 to the negative third. And that's still being raised to the 4x. So now let's simplify each side of the equation here. As I mentioned, on the right, we're multiplying common bases, so I'm going to add these exponents. So we're left with now a single base of 3, and 2 plus 2x plus 1 becomes 2x plus 3. On the right-hand side, I'm raising this power to another power, and that's when I get to multiply the exponents. So the right-hand side becomes 3 to the negative 12x. And now I have both sides with a base of 3, and so I'm able to set these exponents equal because it's an equation. So 2x plus 3 now is equal to negative 12x, and this is a much simpler equation to work with now. I'm going to move 2x to the other side by subtracting it, but if you'd like to rearrange it in a different way, that's fine. We will both get the same answer in the end. So I'm left with 3 equals negative 14x when I subtract 2x, and then I will divide both sides by negative 14, and I end up with a fractional answer, which is fine. X is negative 3/14. So if you want, you could now substitute this back in. It's not a bad idea to make sure that when x is negative 3/14, this side of the equation is equal to this side of the equation. I hope you enjoyed this video and that you are ready to start solving exponential equations on your own.